What's going on, level 2 class? My name is Farai. I'm one of the Avalanche instructors currently at large. Sorry I couldn't be here with you physically or live, but we're going to talk about documentation and record keeping today. We are going to talk about kind of some of the what, why, and how. We're going to dive into some of the specifics around MHSP and you as a patroller and you as a backcountry user. What are some of the options for documentation, record keeping, contribution to the kind of avalanche and snowpack data at large? And then we're going to try to get you some reps with actually recording some of this stuff. So according to NSP, some of the learning objectives for this class, we want to record weather, terrain, and avalanche event observations in an avalanche field notebook. Some patrols have, more formal record keeping and stuff. We are not one of those patrols, and we want to make sure that we understand what the uses of that recorded data can be. So why do we keep records? Well, we want to systematically look at all the data related to the avalanche triangle. So weather, terrain, and snowpack factors. And we want to be able to relate those to avalanche events. We want to do it all in a standardized way that can contribute to the collective data and knowledge for all users of the backcountry and people interested in studying snow science. And also we just want to have a good, solid record of our time in the mountains. Our memories aren't great. I was looking back through some of the pits and some of the data that I recorded a few years ago on a tour, and there was like something about shooting cracks and abandoning a pit and instability that I didn't even remember that it was something that I encountered. So it's great to go back and look at that and have some quantifiable hard data. So in terms of MHSP and record keeping, we don't officially do any sort of recording or reporting as a patrol. There may be some opportunities if you're patrolling at Meadows or some other resort or in partnership with some other organization, there may be an opportunity for some sort of formal record keeping and responsibility that patrol is regularly participating in. But most of our opportunities for record keeping are more for personal knowledge and similar to what just a high-end backcountry user, how they might relate to data collection and reporting. So two primary opportunities to contribute that data are through something called SnowPilot. And then we can also do reporting to NWAC, which helps a lot because they are covering a huge zone and they only have so many sources of data. So the more the community can contribute high quality data, the happier they are, the better it is for all of us in terms of getting a better end product with the avalanche forecast and all that. Some of the materials that you will need. You'll need a field notebook. I have always used one from this company called Snow Pit, and just take you there now. They pretty much just make this product, snowpit.com, and it is an awesome little field notebook that has basically everything that you would need to plan a tour, to systematically think about the forecast, the snow, weather, and terrain kind of factors that go into the tour that you're planning, and then to do systematic data collection in the field, digging pits, recording temperatures, looking at snow crystals, weather, and all of that. So it kind of has like everything that, I'm not ever dragging the swag, like the full swag book out with me unless maybe I'm teaching a class, but all of the most relevant information is included in this little thing. So if you're going on a hut trip or something, I always have this with me, and it's awesome to kind of systematically work through it in the evenings. So there is this avalanche dashboard, which it's sort of a living document. So I'm going to walk you through, I went on a tour the other day specifically thinking about this class, and I'm going to walk you through my process with that. At the moment, I just want to kind of familiarize you with what is available in this notebook. So the two main kind of record keeping sections are this avalanche dashboard section, and then this snow profile data recording section. But all throughout it, there's reminders about how to record that data. There is this tour planner section. There is information on how to conduct the common snow stability tests that we do and how to record them properly. There's wind and weather, and there's different conversions within it that allow you to think about how some of that's affecting the snowpack. There's slope angle gauges, which you can use for different scales of topo maps. And then there's this really handy section on snow crystal classification. And it doesn't have everything. If you go into SWAG, there certainly are more different types of crystal classification than this, but it has the most common. And so it has it by class here, like this is all new snow, precipitation particles. And then if you want to dive into more specifics, it has some of those subcategories. So that is the main thing that I would recommend having in your pack. There also, BCA has some great snow study tools. They've got some thermometers. There's this ARI backcountry decision-making guide field book, which I don't have a lot of experience with myself. I suspect that it covers a lot of what is in that Snow Pilot book as well. You could check that out and consider that as an option. They've got different crystal cards. I have this black aluminum crystal card, and it also has some of the most common snow grain classification types at the bottom there. Just trying to snap in here. Let's see. There you go. So that's a great little cheat sheet. And then you have your 1 millimeter and your 3 millimeter grid. So that is always in my pack. The American Avalanche Association also has this kind of SWAG quick reference sticker. It's all information that should also be in that snow and avalanche field book. So those are just some of the tools available to you. For me, the must-have is this guy right here. All right. Some other things you'll need some sort of a metal crystal card. You'll need a good loop. I'm actually still kind of searching for the perfect one. Yeah, I've got some that aren't strong enough, some that are too strong, some that are really strong, but really a large magnification factor, but don't have a great field of view. So a good loop is super, super valuable to have and a little hard to find the perfect one in my experience. Thermometers, and you want to make sure that they're capable of 0 degrees Celsius. Some, baking thermometers and things are calibrated more towards higher temperatures. You'll need something to measure slope angle, compass to measure your aspect. You'll need a pencil and a knife. Just they're handy things to have in the mountain. And then they also are part of that hardness scale, which we'll use to compare flares. You'll need a probe, shovel, saw, roosh block cord, especially in maritime snowpack that we have. You really do need a good quality roosh block cord. The best one that I found is from Brooks Range, which I think they might have actually gone out of business, but in some other snowpacks, you can get away with like accessory cord with knots tied in it, but I do not find that to be the case in our snowpack. Even with like a great roosh block cord with teeth, it can be pretty difficult to cut through some of the layers that we have. A paintbrush is handy for helping to clean up the side of the snow pit and to be able to visualize the layers that are there. And then popsicle sticks can be helpful to mark those layers once you've identified them, so that they're just super easy to return back to and see in photos and things like that. And then a smartphone is great for also recording, getting more up-to-date weather information. and things like that. So that field notebook has, really all the info that you need in the field once you have the training to actually be able to use it. They've got that dashboards and tour planner, the snow profile section where you can, if you want, you can graph a whole snow profile. Usually the way that I use it is that I record the data that I then turn into a snow profile. And I'm going to kind of walk you through my process with that. But you can graph a snow profile as well. And then they had that glossary section with symbols, classifications, and the rest of it, which we already talked about. What we are going to record in there is we're going to record all the relevant information to terrain, weather, and snowpack. So that's, our location, our elevation, our aspect, our angle. We're going to be looking at precipitation, sky cover, winds, wind loading, the surface of the snowpack, and what does that indicate about the history or the wind loading that's happening. We're going to look at the ski penetration and the boot penetration of when you're just standing in the snow. That is useful to understand something about the density of it. It's a good tool also if you're concerned, depending on what your avalanche problem is, if you are dealing with maybe a wet slide kind of a situation. That's an important piece of information to have as the day warms up. And then we're going to record all the information that is relevant to a pit profile. So that's the layers, hardness, grain type, size, and potentially temperatures. This is just a required slide for the class from NSP, but we don't have any forecast facility forms, or there's not any official record keeping we do. So again, we are going to get out in the field, record the information in our field notebook, and then we can digitize that into a nice, easy to read pit profile on snowpilot.org, which then is also accessible if you choose to share it with the greater community. And you can take that information and you can report it to NWAC, which can take that into account when they're forecasting. So why do we record this stuff? Well, we want to be able to correlate the weather and the snowpack stability. We want to correlate wind and loading patterns on specific terrain. So, we have a general forecast coming from NWAC, some general wind directions, but then you actually get out there and you then want to compare the what that forecast looked like generally to what the actual conditions on the ground are. Like overall, is it consistent? What sort of local wind patterns and loading patterns are you seeing? And how does that all relate to avalanches? What sort of avalanches are you seeing when certain weather patterns are happening? And that helps you to just be that much more knowledgeable going forward and planning future tours, things like that. You also want to be able to compare the specifics of profiles in the same place over time, and also the spatial variability. So if you're in the same zone and you dig, a pit here, and you dig a pit, 50 feet away, what sort of spatial variability are you seeing as the potential problem layer closer to the surface? Is it further away from the surface? Is the slab thicker? Is the slab thinner? Are you having, faceting from some sort of radiation imbalance one place that you aren't having in this other location? Why is that? Is it because of terrain? Is it because of vegetation or tree cover, things like that? So overall, you just want to have actual specific records. You want to have them recorded in a systemized way so that you can make meaningful decisions, meaningful analysis. You can share it with other people in a way that is consistent and easy to understand for them, and that it's useful to the larger data set, which informs all of this kind of decision making, snow stability, snow science stuff that we're so interested in. All right, so I'm going to take you through my use of the field notebook of tour on the 25th, February 25th, and I'll show you how I use it. And then I'm going to give sort of a little data set to Mike to help facilitate you all quickly recording that information, planning a tour, recording information for a pit, familiarizing yourself with creating that snow pit on SnowPilot, and then also where you would go to submit that to NWAC. All right, so hopefully you can see this clearly enough. I'll also give Mike the actual images, so if for whatever reason this recording isn't, the resolution isn't good enough, then you can see it more high quality. But it was the 25th of February, 3 p.m. I was planning to go dig a data pit specifically for this purpose. My partner was my dog, Kaya, which given the forecast for the day and the terrain and my familiarity with the terrain, you know, staying on all low angle slopes, I was below to near a tree line, so low to moderate. You know, it's always good to have a partner. In this case, I felt that I was able to very safely manage what I was looking at. So the top section here is a spot to record the avalanche advisory. So getting it from NWAC, it was issued the night before on the 24th at 6 p.m. This is my above tree line, near tree line, and below tree line. So we had moderate above, moderate near, and low below. Over here on the right, I have the two avalanche problems. So the number one problem that they were concerned about that day was wet loose, and that was on west through east aspects at basically all elevations as the day warmed up. And then the second problem was wind slabs, and those were near and above tree line, but not below tree line. So that probably makes up that difference there between why it was moderate above and low below. So my plan was I was parked at Meadows, and I was going to tour from the south boundary to pit location. Since my goal wasn't really necessarily great skiing, it was just to get some decent data so that we could talk about this. I was going to travel up along that boundary until I got into the more kind of open gladed leeward slopes that were pretty low angle, where I could find a decent spot to dig a pit and record some data up near Mitchell Ridge. And then here's what actually happened. I did actually, you know, end up skiing the plan. So sometimes that's not the case. When I was looking through an older recording I had, the plan was to go up and dig a data pit when some friends and I were figuring out the snowpack on a hut trip. And when we went to do that, another party reported that they had like a 10-meter shooting crack above them. And so we abandoned the plan and went to lower terrain. But this day, here's a plan, and that was actually what we did, what I did execute. So I'm going to jump down to this bottom section here, and that is a spot to record the weather. So you start with this the night before when you're planning your tour, you know, a couple days before or whatever. So I was looking at the weather the night before, and there was good weather data for the elevation, the approximate elevation between 5,000 and 6,000 feet that I was interested in. So we've got our time, our elevation. The wind was coming from the west-southwest. C is for calm, and that is all in that field notebook. There's cheat sheets for that. The sky was slightly covered. So I don't know if you can see any of this. It may be backwards too, but there's all these official different ways that you record sky cover. So I had just a little bit, few scattered clouds, less than a quarter of the sky. So that's what that little quarter pizza wedge is. The temp was 15 degrees Fahrenheit. It probably is a little sloppy. Probably better if I recorded it in Celsius, but that's what it was. And then no precipitation. And then here at that same time, I recorded the forecast, which NWAC issued, which was basically more of the same. It was like maybe a little bit warmer, which is where we have some of that concern for wet loose coming in, but clear skies, calm winds, et cetera, et cetera. And then here's the actual like weather that I recorded that I noticed when I was out digging my pit. And so this was just a short couple hour tour to do this. If I was doing a big hot trip or a multi-day tour, then there's options to continue recording that weather and to see what sort of trends are developing over time so that you can make sense of where everything's going. I didn't record all this information in the moment. Some of this as I was touring, I was dictating some of it to my phone, which can be super useful. And so I'd actually also been skiing at Meadows and that day before I did this, and I had good exposure to all sorts of different elevations and aspect and all this, and different conditions because it was more skied on. But I got up high and went out to Clark Canyon and found some decent snow, but things were generally had firmed up a bit or were kind of mashed potatoes, some of the stuff that was directly in the snow. But when I went touring down in the lower elevation, I was pleasantly surprised in the shaded areas of stuff that had been less sun affected and had stayed cold. There'd actually been a slight inversion before this, and just things were generally farther away from freezing than they oftentimes are on Hood. Anyways, I found some really great snow in the, especially stuff that was in the shade. And as long as it wasn't affected by the sun or the wind, I found some great 16 inches of unconsolidated snow. You can see that I marked elevations on this rows here. So I chose 4,500, 5,500, 6,500 because that was the most relevant to what I was specifically interested in. You could keep it really general, like how NWAC does, and you go, below tree line, near tree line, above tree line, whatever you want to do. Or you could have a way bigger scale. It could go from 2,000 feet to 10,000 feet if you were interested in climbing, to the summit. So you can different people have different approaches for how they record this information, but choose your scale, record it in some way. So, this was an attempt at some shading for where the aspects that I was mainly finding that unconsolidated snow. So it was mostly that that lower below tree line and the near tree line. As I got above tree line, the snow had been more sun affected and was a bit firmer. And it was also potentially more wind affected. So less of that light fluffy powder. And the real sun affected stuff, I had, a breakable crust, just some general kind of melt freeze stuff happening. And I also wrote just a tiny bit of dialogue about that. Here is something that I did way after the fact, which was just record the exact pit location and the results that I got. So I ended up digging at ECT, and as expected, based on the forecast, based on what I was seeing, I got no collapse, no propagation, nothing. So ECTX, which if I thought I was going to get anything more than that, I probably wouldn't have just gone touring with my dog. And then one handy little thing is I wrote Alp Truth on the side. Anything to sort of help you look for those, big obvious clues, whether it's 5 red flags or whatever, and then just put an X near what you see. So A stands for avalanches in the past 48 hours, not that I was aware of, so no check there. Loading by new snow or wind in the past 48 hours, I did mark that. There was a little bit of loading. There certainly had been some in the past, nothing that was reactive, but I had to check something for you guys at least. P is paths where avalanches have run before. The terrain that I was in was real low angle, so wasn't a significant path. And I was avoiding terrain traps, which is the T. The rating was not considerable or higher. And I didn't see any signs of instability of unstable snow, which is the U. So there's no woomping, cracking, punchy snow. And thawing of the snow surface or rapid warming, there was some warming, but it certainly wasn't rapid. So yeah, so that's that page. And I'd come back to that a year from now and I'd have a really great jarring of my memory of what I saw that day. Here are some of the layers that I found. Here's the side of the pit. I dug a meter deep pit and I found all these different layers. I found a few crusts from some just high pressure, that we've had a couple weather events with warm temperatures, some rain, whatever, that have caused these very steep crests. Some temperature measuring. To be honest, this is probably the thing that I could improve on the most, just maybe dialing in some different thermometers. I was a little bit rushed because I had a dog who wasn't super interested in sitting around for 3 hours while I did this. So if there's anything that my confidence in my data is not super high on, it's probably the temperatures. And, just in general, all this is kind of an attempt to quantify. Temperature is not a great example of this, but snow stability, you're trying to sort of quantify and organize and communicate a lot of things that are somewhat subjective, or at least that have not a super high degree of accuracy or confidence in. So recording this data and doing it in a way where you are cognizant of what you were 100% sure about and what, is it sort of a theory with some degree of confidence, and what you have really low confidence in, is all part of the name of the game. Temperature, that's probably one of the worst examples, and I should have that totally dialed. So here is it was 22 degrees was the slope on the pit that I dug it in. Here's a attempt at a little iPhone photo of some of I believe this was the grains on the surface, which were kind of, there were some plates and some needles, I would say. It was all, but that's kind of more specific. If you weren't really sure, then you could definitely just call it all precipitation particles and just go for the plus. Here's some, I would say, some rounds, some 2 millimeter rounds. This is on the 1 millimeter grid side of that BCA black aluminum crystal card. Rounds or maybe melt forms. I was kind of thinking that they were melt forms, and that was what I was finding lower in the pit. And then here's the pit itself. So, I feel like it's pretty good looking pit. Got vertical walls. It did a good job of isolating it. And you can see from the snow that's missing on the right side on the top that it was an ECT, and I didn't get any sort of collapse or propagation. So ECTX. So that's just kind of generally what it looked like. And then here is a couple pages deeper in that field guide. And here's how I recorded it. And so I have the date, the time, reference. I have the specific GPS coordinates, elevation, the aspect, it was east southeast. At the time I wrote 20, but looking back, if it was 22, not really too meaningful of a change. Precipitation none. Sky was clear. You can again reference the cheat sheet in the back of the field guide. The wind was coming from the west. It was calm. And your other options are, and there's a whole kind of guide for this, but calm, light, moderate, strong, extreme. And I'll just let you look at that yourself sometime. Loaded, it was a little bit of wind slab activity. It was a little bit wind loaded, and the surface was wind affected. When I was on a snowboard, but skinning, and I was getting about 10 centimeters of penetration when I had my big wide split board ski on, and then about 25 centimeters when I was just in boots. So I was the one observing. It was a data pit, and my measurements were in centimeters and Celsius temperatures. So after basically the process was dug the pit, took the crystal card, identified the different layers, and you saw back in that photo that I kind of took that crystal card and really marked those layers. If I had popsicle sticks, that would have been another great way to look at the layers. So I have all these different layers. I then measured I recorded the depth of each one. So I had one that sort of was 0 to 29 centimeters, 29 to 36, 36 to 39 was this kind of something that was a little bit more like a crust. And I was trying to identify a lot of layers. I probably could have generalized it a bit more, and you can see, like, especially all these layers here between 48 and 62, it was basically like 2 to 3 millimeter rounds, pencil plus hardness. So that probably could have been its own layer, even though I sort of noticed some differences between them. So I went and I noticed all those layers. I went and I recorded the hardness, which the scale is also down here at the bottom, if you can see my mouse here. So we've got fist, which is a gloved hand and a fist, 4-fingered, gloved hand, 4 fingers, I forget what the specific measurement of pressure is, but it's been described as like if you're pushing a full pint of beer across a bar, or it's sort of like if you're pushing your hand into your nose, the amount of pressure when it starts to become a little bit uncomfortable. So fist, 4-finger, 1 finger, that's all with a gloved hand, pencil, knife, and ice. So I recorded these different hardnesses. I looked at them under a loop. I had just a 10x loop, and I had like this whole crazy microscope I was experimenting with, which the batteries were dead, so that wasn't very useful to me. And so on the surface, I found these new, these precipitation particles, which looked to me like they were sort of 0.5 millimeter plates and needles, and needles, yeah. And then it was basically a bunch of like rounds, a couple layers of ice, and some melt forms that I was seeing down at the bottom. On the right side here, then I've got these depths. So just every 10 centimeters, I was taking the temperature, and it started with the air being -4 centigrade Celsius, and down at about 0 at the bottom. And just generally the temperatures that you're going to see in pits are the ground is 0 and the air is whatever the air is. And then you get this sort of temperature distribution up through the snow, and the greater that you have like a quick change, the more likelihood you have that there's going to be some drying out of the snowpack, some faceting, and that's how depth hoar is formed. So this is why temperature is important. It's like you're basically asking the question of like, okay, here's what the snow is right now. I know this, I'm looking at the layers, and where is it going? Is there some sort of significant temperature gradient that is causing things to become weaker, causing faceting to happen, causing the snowpack to dry out? Or is there not? Is there a lack of that, in which case things are trending towards stability? And really generally that sort of is a function of how cold is the air temperature and how shallow is your snowpack. And so for us, usually the air temperature is not that cold. This was actually like maybe a colder day than we oftentimes have. A lot of times the air temperature is hovering around, freezing basically, right? And so if like the ground is freezing and the air temperature is a few degrees colder than freezing, and we have 10 feet of snow, the odds of you having some significant temperature gradient that's drying out the snowpack is pretty low. So things on Mount Hood and maritime snowpacks in general tend to really be strengthening over time. You probably talked about that in a different section though. So I was doing it every 10 centimeters. And then I also sort of noticed what seemed like a bit of a jump around, 50 to 60. And so then I was like, oh, well, let me actually like go back and look at this 55. And so that's why it's out of order. And yeah, okay. So did my test, ECTX, which is what I recorded there. And then I later went back and I recorded that in the location here on my tour planner, avalanche dashboard, what have you. Cool. So then, great. That was the data collection part. Now, like, what do I do with it? Well, I made a decision. I went and skied the low angle slopes that were shown to be stable to me based on the forecast, based on the observations, and based on the, I wasn't seeing anything in the snow layering that was causing me great concern, and I wasn't seeing anything in my stability test that was causing me great concern. So I went and skied it, great, got home. Okay, so this is also supposed to be our recording, so let's talk about that. All right, so there is this great thing called snowpilot.org, and you can register for an account, and you can affiliate yourself with MHSP if you would so choose, and then you can create a snow pit. So I already made this one, so let's take a look at it. All right, so we've got all that information, the coordinates, the slope angle, which I got correct there. The wind, we've got the height of the snowpack here, 100 centimeters, the ski penetration, and the foot boot penetration. So that's what's going on there. You have to choose a problematic layer. I chose this top one, you know, thinking about the wind slabs, thinking about the warming, even though, you know, an ECT is probably not necessarily the best for testing the warming for the wet slide. But anyways, I did that, and then it graphed. I chose all the different layers. I put in the layer types, I put in the crystal size, and it created this graph for me and this temperature graph as well. Feel very good about my hardness ratings. I feel good about my overall layer depths. I feel okay about my temperature. It's generally things kind of go from colder to warmer in a somewhat consistent way, and you have a jump. This part that kind of jumped here, you know, maybe I wasn't being as precise as I could. Maybe I could get some better thermometers. Anyways, I don't know. That's my one sort of caveat about this pit. Here's the ECTX that I got, and then I also uploaded some of those photos that I already showed you. Those coordinates populated this map, which is very slowly resolving itself. There we go, sort of. So you can just see exactly where that was. And so that was kind of, you know, below, here's like a Vista, or there's the top of Vista. So anyways, outside the boundaries of Meadows. Great, so I have some data that we're probably running out of time a little bit on this session, but I'm going to give some data to Mike or whoever's facilitating this, and I want you all to go through the same process of generally planning your tour, recording some of the observations that you experience when you're on the tour, and really generally recording a few different layers in the snow pit and test results. Come into SnowPilot, and you're probably gonna have to do this part on your own, but go through making a snow pit. When you do it, don't submit an actual snow pit. And I would just perhaps as a caveat, yeah, I would just like your first couple pits, get a little bit of practice with this before you go and start like making them totally public. But you can name it, choose a time, check this practice pit. So when I'm doing that one I made, you know, I checked this practice pit so that people sort of knew that it was more about this class than it was like super high quality data. And I also wrote in the snow pit name that it was practice pit. And then I turned the visibility actually for mine to visibility, visible only by me. You could have it visible by MHSP folks. I'm not going to walk through every single piece of this because there is a good 10-minute video that they have here on the SnowPilot page, and they can walk you through it. And probably be good to hear somebody else talk other than me. But basically, there's these different tabs. You got that core info. You record your layers here. Yeah, that's fine. You record your stability test results. So for me, that was this ECT. It didn't do anything, and that's fine. Temperature profile, you just add these temperature recordings, and then density, we're not doing density. I didn't do density. So that is the gist of that. And then here, if you come to NWAC /observations/submit, then if you saw something meaningful, you dug a pit, you want to communicate just a sort of dialogue about what you saw mountains to NWAC, or you want to take that nice, pretty pit profile that this generates, if I can figure out how to get back there, then you could just like save this as a JPEG and upload that to NWAC. So that's basically the gist of it. So that is, you know, why we collect data, how we collect data, what we need in the field to collect data, and specifically for you as a MHSP patroller and a Mount Hood backcountry user, and just backcountry user in the NWAC forecasting region in general, how you can collect and contribute that data and record it in a meaningful way. So one of the instructors will walk you through getting a little bit of time hands-on with this. Feel free to give me a shout if you have any questions. And yeah, happy skiing. All right, thank you.